Part C says, find the equation of the graph. Assume the basic function could be sine or cosine. Let's start off with cosine, since we know that by looking at the graph, it already has this U shape where it starts at the top and then goes to the bottom. And then we can figure out the sine transformation after that. So I know that the highest y value here is 2 and the lowest y value is -4. And if I average those two numbers, 2 plus -4, and then divide that by 2, the numerator is -2 and the denominator is +2, and that gives me -1, which represents the center. So if -1 is kind of the center vertically, that tells us a couple of things. Normally the center is at 0, so the graph was shifted down 1 unit, and then that also tells us if the center is at -1 and the distance from the center to the top is 1, 2, 3 units, then there's a vertical stretch, and that tells us the amplitude. So if we are coming up with a function, we have f of x is equal to our base function. We decided we were going to start with cosine, and we have figured out that the amplitude is 3 because the distance from the center to the top point is 3 units. And then we are taking cosine of something, and we know that it was shifted down 1 unit. So I'm going to go ahead and put this -1 at the end. And now we want to figure out what goes inside the parentheses. And you can tell here that we have one complete period of our graph where I've highlighted it. And if we're starting at 0 and ending at pi, then we know that our period is equal to pi. And from a previous video, or in this outline, a previous example, we saw that the period is equal to 2 pi over k. So we can set that equal to pi since we have that information there. And then we can solve that for k. So if I cross multiply, then we get k times pi is equal to 2 pi. And then I can divide both sides by pi. And then we would end up getting that k is equal to 2. So here, the thing that we're multiplying by x would be 2. That's our k value. And then we're just going to have x here like that. And that is our answer. If we are thinking about this in terms of cosine, we can set up another equation that is in terms of sine. Okay, so now let's think about sine. And we know that sine, when we're starting off on the unit circle at 0 degrees, we know that the sine value at 0 is 0. And so our sine graph is going to look a little bit different than cosine, and it's this region here that I'm highlighting in blue. And we start there at the center, and the amplitude in this example is going to be the same, but notice that this one has a phase shift since we are not starting on the y-axis. So we have to identify the graph is shifted this many units, which if you look, each tick mark represents pi over 4. So we have a shift of pi over 4 units to the left. And so maybe we'll call this g of x equals, the amplitude is still 3, sine of, we'll figure out some stuff there, and the vertical shift here is also going to be -1. And The general form is going to look like k times x minus b with that extra set of parentheses on the inside, where k is determined by the period like we did for cosine up above, and b is the phase shift. Notice again, just to reiterate, that there is no phase shift here because our graph started on the y-axis, where here, if we're thinking about this in terms of sine, it's been shifted to the left a little bit. So hopefully you can remember from pre-calculus that if we have shifted to the right, then we need to add to the x value, and the amount that we've shifted over was pi over 4. So we have x plus pi over 4 because we are shifting to the left pi over 4. Now we just have to figure out what our k value is, and it turns out that the k value is going to be the same because our period is starting here and ending here. So this x value is negative pi over 4, and this x value here is 3 pi over 4. And if we calculate the distance between that, that is still pi units. And so this is our period. And so if we did 2 pi over k is equal to pi, our period, if we solve for k again, we'd get k equals 2 pi over pi, which is equal to 2. So I'm going to go ahead and erase this and substitute in our 2, and this would be our equation if we were thinking about this graph in terms of sine. Now you might be looking at this and thinking, oh, that's so weird, how can both of these things be equal? So I just wanted to quickly show you here that both of these functions, y equals 3 times cosine of 2x minus 1 and y equals 3 times sine of 2 times x plus pi over 4 minus 1, are both graphed here on Desmos. And notice that I can remove the blue graph, which is the sine one, and we have the red one, and they are right on top of each other because they produce the same graph. So I just wanted to quickly illustrate that both of these equations are actually have the same graph. And that concludes this example. All right, let's look at this next example. We're given a graph and we want to come up with the equation for this graph. And notice here that vertically the center is at 1, and then we can measure the distance from the center to the highest point, and that distance is 2 units, and so our amplitude is going to be 2 here. And notice that there is no phase shift since we are starting our first value on the y-axis, and then 1 full period is what I have highlighted here. And notice that the distance from here to here is from 0 to pi, so that is pi units, or period is pi. So let's construct our equation now. So we are going to have y equals 2 times cosine of something, and then also notice since our center vertically is at 1, we need a vertical shift. So I need that +1 on the outside of the parentheses. Again, so we need to figure out what k is. So we have k times x. Notice that if there was a phase shift, it would be k times x minus b, like that. But again, since we're starting on the y-axis, b is equal to 0 in this case. So we just need to figure out what k is, and we know that the period is equal to 2 pi divided by k, and that is equal to pi. And this is similar to a previous example that we just saw. So if I solved that for k, we would get 2 pi over pi, which is just equal to 2. And so I can replace this with 2 here, and this would be my equation for this graph. All right, for this next example, we are given a graph and we're given a bunch of information. This one's nice because it tells us the period, the amplitude, and the phase shift, which we need all of those things in order to construct our equation. Now, I'm going to, since it specifically says that the phase shift here is negative pi over 6, that means that we're starting here at this location. And so that tells us that this is going to be a sine graph. And another thing that we need to notice is sine normally goes up. And so it would go something like that. And so we would need to recognize that there's actually a reflection over the x-axis. So let's think about that as we are constructing our equation. So we have y equals a times sine of k times x minus b, and then plus some value. I'm just going to call it c. You can call it whatever you'd like. It's just a variable. It doesn't matter too much. All right, so let's deconstruct each of these parts. So we have y equals, we know our amplitude is 2, and I said earlier that there is a reflection happening over the x-axis, so it turns out that the a value needs to be negative 2, and we have sine of, let's take a minute to think about what k is. We'll come back to that. And we know here that the phase shift is negative pi over 6. And if it's shifting to the left, then we need to add. So it's going to be x plus pi over 6. And then notice that we are starting our center at the x-axis. So there is no vertical shift happening. So our c value is going to be 0, but typically we don't write plus 0. So I'm just going to erase that portion. So now all we have to do is we need to figure out what the k value is. And we are already given the piece of information that our period is equal to 2 pi over 3. So let's go ahead and take that 2 pi over 3 and set that equal to 2 pi over k. Now if we cross multiply, we get 2 pi times k is equal to 2 pi times 3, which is 6 pi. And if we divide both sides by 2 pi, we get k equals 6 divided by 2, which is 3. Also, I could have done this in a much shorter way, because notice that these numerators are exactly the same, which if these fractions are equal would imply that these denominators would have to be the same. So I basically kind of did all of that work, and it was unnecessary to see that our k value is 3. So in my equation now, I'm going to now replace that with 3, and this is our final answer for this question.